In this exercise, I'd like you to use classes to model a person that contains a name, age, and height properties. So given the following program that defines a person as a map object, then refactor this code by creating a person class that will contain name, age, and height properties. This class should have a print description method that can be used to print the name, age, and height, just like in the program above. And once this is done, create two instances of person and use them to call the print description method just created. So take your time to solve this exercise using what you have learned about classes, and then I'll show you the solution. Okay, so let's see how to solve this. And the main purpose of this exercise is to use classes to model a person so that we can represent these properties. So let's see how to do this. At the top of the program, we can type class person, and then inside the class body, we need to add these three properties. Now, the text of the exercise didn't say anything about whether these properties should be mutable or not. And in this kind of situation, it's best to declare immutable properties so that there are less chances that our data can be modified by mistake. So here we can declare three properties as final string name, final int age, and final double height. Next, we want to add a constructor for these three properties. And to make things easier, we are going to use named arguments and declare each argument as required. Like this: required this.name, required this.age, and required this.height. So this is all we need to create instances of type person. Next, let's add a void print description method, and then we can move this print statement from here to here. And then we can replace these expressions with $name, $age, and $height, because these are the names of the member variables in this class. Okay, so let's format the code. And now in the main method, we can declare a couple of instances of this class. So here we can type final p1 equals person with name Andrea, age 36, and height 184. And then final p2 equals person with name Lucy, age 44, and height 176. And to print the descriptions, we can type p1.printDescription and p2.printDescription. And if we run this program now, we can see that we get two lines, which is the output that we expect. Okay, so this completes this exercise, and let's continue on the next lesson where we will use this example program to talk about type safety with classes. The exercise that we just completed is a great example of the advantages of using classes over maps when we represent something like a person object. So let me show you what I mean. Over here we have a map object which represents a person using key value pairs. However, using a map like this is very error prone. For example, it's easy to make a mistake and add a typo in one of the keys. For example, here I could spell height incorrectly. And it can be hard to spot a mistake like this, because this is just a string literal, and the type system can't help us here. On the other hand, if we made the same mistake by misspelling this argument name here, then Dart would give us some errors, and we can more easily fix this. Okay, so let's fix this. And another mistake that we could make in this example is to represent the age with a string rather than an integer. And this is valid code because the values of this map are dynamic. On the other hand, the same mistake will be caught immediately when we create a class instance, because Dart can tell us that the argument type string can't be assigned to the parameter type int. So the bottom line here is that whenever we are trying to represent some real-world concepts and we know that these have some well-defined properties such as name, age, and height, then we should use classes. And you know what? I know that programmers are lazy, and sometimes you may be tempted to just use a map like I have done here. As a programmer myself, I can tell you that sometimes being lazy is a good thing, but this is not one of those cases. So do the right thing and use classes, because this way you can use the type system to your advantage and avoid many mistakes that would be otherwise hard to catch. In addition to this, classes are self-documenting, and people reading your code can more easily understand how to use it correctly. Okay, so let's continue on the next lesson. In this lesson, we are going to talk about const constructors. As an example, suppose that we want to create a class to represent a complex number. And in mathematics, a complex number is a number that can be represented by a real part and an imaginary part. So let's see how we could model this in Dart. So over here, we can type class complex, and then inside the body, we can add two properties to represent the real and imaginary part, like this. And we are making these final so that they cannot change once they are created. Next, we need to add a constructor. This will be called complex, and it will take the real and imaginary parts as arguments. And then inside the main method, we can create objects of this class by typing final complex equals complex, and we can pass 1 and 2 as arguments, for example. And if you remember, when we create variables of any of the existing types, we can declare them as const. However, look at what happens if we try to declare this variable as const. This generates two errors telling us that the constructor being called isn't a const constructor, and const variables must be initialized with a constant value. So how can we fix this? Well, since this class has only immutable variables that are declared with final, then it is best to declare it with a const constructor, like this. And once we do this, then the errors go away. So as a best practice, when you create a class that has only immutable final variables, then you should give it a const constructor. And when you do this, the compiler can do some optimizations and make your program more efficient. On the other hand, if one of these variables is not final, then you will get an error because you can't define a const constructor for a class with non-final fields. And this makes sense because if this variable is mutable, then instances of this class can't be const in the first place. Okay, so let me make this variable final again. And by the way, since this class has a const constructor, you can also use it to define a const list literal, and inside it we can add complex numbers, like this. So the bottom line here is that when you create a class with a const constructor, you can use it to create instances that are compile time constants, just like you do with built-in types such as int, double, or string. And you can also create const collections containing instances of your class. Okay, so let me remove this code from the main method and we can continue on the next lesson. It's now time to learn a bit more about constructors. When we create a class in Dart, this can have different kinds of constructors, and these are the default constructor, and we have an example of this over here. But we can also have named constructors and factory constructors. So in this lesson, we're going to learn about named constructors. You see, in this example, we have created a class that we can use to represent complex numbers. Now, this works, but there are some special complex numbers that are used quite often in practice, and these are the complex number 0, the identity number, as well as numbers that have only the real part or only the imaginary part. And if we wanted to create these kind of numbers, here we could type final 0 equals complex with arguments 0 and 0, or final identity equals complex with values 1 and 0, and also final real equals complex with values 3 and 0, for example, and final imaginary equals complex with values 0 and 4, for example. Now, this code is fine, but it would be better if we could have some special constructor names that we can reserve for these numbers. And to do that, we can use named constructors. So let me show you how they work. Inside the class declaration, we can add a new named constructor called complex.0. And then we can use an initializer list to set real part to 0 and the imaginary part to 0. As you can see, we can define a named constructor by typing the name of the class, followed by a dot, and then the name that we want to give to our constructor. And because we are using this to represent the number 0, we don't want this constructor to take any arguments, and instead we are using the initializer list to set these variables to 0. And here we could add another named constructor called complex.identity. And in this case, we can use the initializer list to set the real part to 1 and the imaginary part to 0. Then let's add another one called complex.real. And in this case, we are passing the real value as an argument so that it can be set from the outside. And in the initializer list, we can set the imaginary part to 0. Finally, we could add one last named constructor called complex.imaginary, and this time we are passing the imaginary part as an argument and we are setting the real part to 0. And since these member variables are final, we can make all these const constructors like this. And now that we have all these named constructors, we can modify these declarations and replace this call with complex.0, and this call with complex.identity, and this call with complex.real with an argument of 3, and this call with complex.imaginary with a value of 4. And the good thing about this is that this syntax is more readable and easier to use, and it makes it harder to make mistakes by passing the wrong arguments. In fact, these two constructors don't take any arguments at all, and the correct values are set for us in the initializer lists. So named arguments are all about giving you a more expressive way of creating specific instances for your classes. And by using them, you can make your classes easier to use correctly and harder to use incorrectly. Okay, so we have now talked about the default constructor as well as named constructors. And as I mentioned before, there is also another kind of constructor, which is called the factory constructor. However, we will cover this later on in the course once we have talked about inheritance. Okay, so let's continue on the next lesson. In this lesson, we are going to get a bit more practice using named constructors with a new example. Suppose that we want to create a class to represent a temperature value. And as we know, temperatures can be expressed using degrees Celsius or Fahrenheit. So let's define a class that can take this into account. Over here, we can type class temperature, and then inside it, we can add a double Celsius member variable. And suppose that we want to keep this variable mutable so that we can change its value. As usual, we need to add a constructor. So over here, we could type temperature, and then as an argument, we can pass this dot Celsius, like this. And then in the main method, we could create a final temp equals temperature. And here we need to pass an argument. However, we now have a problem because it's not clear from this call if we should pass a value in degrees Celsius or Fahrenheit. And the reason this is not clear is that the constructor of this class is badly designed. So let's make this better. And what we want is to have two named constructors. One for creating temperature objects using Celsius and one for Fahrenheit. So let's turn this into a named constructor called .Celsius. And because we made this change, we are now forced to write this call as temperature.Celsius, and we could give it a value of 30, for example. So this is much more clear. Next, let's add another named constructor called temperature.Fahrenheit. And this time we can't use the this dot syntax because we need an argument that represents the value in Fahrenheit. So we can declare this as double Fahrenheit. And then we can use an initializer list. So on the next line, we can type colon and then Celsius equals, and then within parentheses, Fahrenheit minus 32. And then we can divide this by 1.8. And this is the formula for converting Fahrenheit to Celsius. And then in the main method, we could rename this variable to temp1. And here we could declare final temp2 equals temperature.Fahrenheit with a value of 90, for example. And as you can see, when we read this code, it is completely clear whether we are creating a temperature object using Celsius or Fahrenheit. So this is another example of how we can use named constructors to improve our type design. However, our job is not done yet, because once we have an instance of this class, we can print a temperature in degrees Celsius, and we can also set a temperature in degrees Celsius, like this. But we can't do any of these things in Fahrenheit. So let's continue on the next lesson where we will see how to do this. In the last lesson, we added a class to represent a temperature value in degrees Celsius or Fahrenheit. And so far, we are quite happy with the design of our constructors. But we don't yet have a way of getting or setting the temperature values in Fahrenheit. And to improve our class, here we could add a double Fahrenheit method which takes no arguments, and we could use the arrow notation to return Celsius times 1.8 plus 32, which is the conversion formula. And then if we want, here we can print temp1.Fahrenheit using parentheses because this is a method. However, it is a bit odd that we need to do this, and instead it would be nicer if we could just omit the parentheses so that this call looks a bit more like this. So rather than declaring Fahrenheit as a method, a better solution is to use a getter. To do this, here we can remove the parentheses so that this is no longer a method, and then we can add the get keyword between the type and the variable name. And this will turn Fahrenheit into a computed variable that we can access like this. And just to be clear, when you declare a getter variable, you need to provide a body, just like you do when you define a function. Otherwise, you will get an error. And you can use a getter to declare a variable that can be directly computed from some of the other variables in your class. For this reason, getters are also known as computed variables, while regular member variables are also known as stored variables because they are stored in memory. So this is how a getter works, but we can also declare a setter. Let me show you how. Over here we can type set Fahrenheit, and then within parentheses we can add a double Fahrenheit argument. And then on the next line we can use the arrow notation to calculate the value of the Celsius variable. And here we can use the same formula as we have used over here. And now that we have this in our main method, we can type temp1.Fahrenheit equals 90, for example. And when we do this, what happens is that this setter is called using 90 as an argument, and this is used to compute the corresponding value in Celsius. So this is how getters and setters work. And our temperature class is now complete, and we can use it to work with degrees Celsius or Fahrenheit in a type-safe way and with a very expressive API. And I'd like to point out that a temperature value is something that can be expressed with a simple number like this, but a number by itself doesn't carry any meaningful type information. Instead, by creating a temperature class, we managed to create a type that we can use to represent both Celsius and Fahrenheit without any confusion. So once again, classes are a great way to define new types, and the type system can help us to use them correctly in our programs. Okay, so let's continue on the next lesson. In this exercise, I'd like you to add some functionality to an existing class. So given the following class that represents a restaurant with a name, cuisine, and a list of ratings, add some functionality to this class so that it can be used to get the total number of ratings and calculate the average rating. And you can use a for loop or the reduce operator to do this. You can create new getter variables or methods depending on what you feel is most appropriate. And you should use Dartpad with null safety to complete this exercise. Okay, so you can try to complete this by yourself, and then I'll show you the solution. Okay, so let's see how to solve this. So first of all, we want to add some logic that we can use to return the total number of ratings. To do this, we can declare a new int getter variable, and we can call it num_ratings. And we can use the arrow operator to return ratings.length, like this. Next, we want a way to calculate the average rating, and for this we can create a new double average rating method, and inside the method body we are going to use the reduce operator. So here we can return ratings.reduce, and this is a closure that takes a value and an element argument, and we can use this to return value plus element. So the result of this expression is the sum of all the ratings in this list. And to calculate the average, we need to divide this expression by ratings.length, like this. However, this code will only work if there is at least one rating, but if there are no ratings, then here we are doing a division by 0. So to prevent this, we can add an if ratings.isEmpty, and then we need to decide what to return. One option would be to return null to indicate that there isn't an average rating, or we could return 0. And the right answer depends on how we are going to use this method in practice. To keep things simple, here we could just return 0. Or if we wanted, we could return null. But if we do this, then we get an error, and we have to change this return type to a nullable double value. And we need to keep this into account when we use this method. Before we continue, I'd like to point out that here I've chosen to use a getter variable to return this ratings.length variable. and that's because we are not doing any kind of heavy computations here. On the other hand, here I've chosen to make this a method because in this method's body we are calculating the sum of all the items in the list. And if this list has many values, then this could become an expensive operation. And in general, if you need to compute a value and this could require some heavy work, then it's better to create a method rather than a getter variable. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about static methods and variables. So let me show you what static means and how it can be used with an example. One thing that I often do in my projects is to create a class strings that contains all the user-facing strings that I need to show in my app or program. And the way I use this is to declare a static string welcome variable and assign it with this string literal. And here I could have another one called static string sign in equals sign in. And then in the main method, I could print strings.welcome and also print strings.signin. And the important thing to notice here is that here, in order to reference this welcome string, I didn't have to create an instance of the strings class by calling a constructor like this. And that's because this variable is declared as static. In other words, static class variables are variables that belong to the class itself and not to any specific instance of the class. So let me remove this line. And just like we can create static variables, we can create static methods as well. For example, here I could add a static string greet function that takes a string name argument, and I can use the arrow notation to return hi $name with string interpolation. And then in the main method, I can type print strings.greet with Andrea as an argument. Now, if you remember, when we introduced the const keyword, we said that const is used to declare a compile time constant. And these two strings that are declared here look a lot like compile time constant, because it's unlikely that we would want these to change while the program is running. For this reason, we can declare them as static const, like this. And since we have type inference, then here we can drop the string type, because Dart will automatically infer this from the initializer. The bottom line of this is that you can use static to define variables and methods that are specific to a class, rather than instances of that class. And if you declare a class variable as static const, what you are doing is to define a global constant that belongs to that class. This can be better than having constant variables in the global scope, because you can put all these strings that belong together inside a class. And to access static methods and variables outside the class, we need to use this syntax. As a final note, I'd like to say that if you have a regular non-static method inside the class, for example, void foo, then inside here you can type something like this, print strings.welcome. But since you are already inside this class, then this syntax is redundant and we can omit the class name and just type welcome, like this. In summary, the static keyword is quite useful because it allows us to define variables and methods that belong to a class rather than to instances of that class. And we have just seen an example of this. Okay, so let's continue on the next lesson. In this lesson, I'd like to talk about private variables and methods. Private variables and methods are essential in object-oriented programming because they allow us to encapsulate certain things that should not be accessible outside our classes. To show you what I mean, here I have a simplified version of the bank account class that we created earlier on. So in this example, we have a bank account class with a mutable balance variable, and I have included this deposit and withdraw methods that we can use to add or take money from our account. Now, one thing that I should point out is that when we use instances of this class, we should only be allowed to use these methods and not to modify the balance directly. But at the moment, it is perfectly valid to create a bank account like this. And if we want to be cheeky, we can type bankaccount.balance equals 100,000. And this way we can set the balance directly. And that's because the balance is a public member variable for this class. So it would be nice if there was a way to make this variable private or inaccessible outside the bank account. Now, Dart has a very unique way of declaring things private, and that is to use an underscore. For example, here we could make this balance variable private by renaming it to _balance. And then we need to update all the references to this variable, like this. But as we can see, Dart still lets us set this balance variable, and this should not be allowed, because we said that adding a leading underscore to our variable names makes them private. And the reason this code doesn't produce an error is that in Dart we can declare things to be private at the file level. What this means is that because the main method lives in the same source file as the bank account class, then it can access all its private variables. However, in Dartpad we can only ever write code in a single file, and this means that in order to show you how to use private variables, then we need to head over to Visual Studio Code and create a project with 2 separate Dart files. So let me show you how to do this. Over here I have a VS Code window that I've opened inside an empty folder. And you can do the same thing by creating an empty folder anywhere on your system and opening it with Visual Studio Code. Then over here in the File Explorer we can create a new file called bankaccount.dart. And then we can move over to our Dartpad instance and we can copy the contents of this class and paste them inside here in our bank account file. Then we can save this file, and then in the File Explorer we can create another file called main.dart. And then we can grab the contents of the main method from our Dartpad and we can paste them in here. And as we can see, here we get an error telling us that the function bank account isn't defined. To fix this, we can move our cursor here and press Command dot or Control dot on Windows, and we can select this option to import library bankaccount.dart. So this automatically imports the bank account file that we have created so that we can use this class in our main file. So as we can see, this line is now valid, but we get an error on the next line telling us that the setter underscore balance isn't defined for the type bank account. And that's because we have made this member variable private in the bank account class. So we can remove this line from here, and instead we can type bank account.deposit with 100, for example. And this code now compiles. Okay, so by making the balance a private property, we are no longer able to set it outside of the bankaccount.dart file. However, now we have another problem, because here we could try to print bank account dot, and as we can see, the balance doesn't show in the list of available methods and variables. And that's because it is private. To solve this problem, we can go back to the bank account file, and here we can add a double get balance, and then we can use the arrow operator to return underscore balance. Then we can save our file and get back to the main file. And now if we print bank account dot, we see that the balance appears, and we can print it like this. And now we can open the terminal, and if we run dart main.dart, we can see that the output is 200, which is 100 plus 100. In summary, we have now seen how to declare private member variables inside a class, so that it's not possible to set this balance variable outside this file. And we have used a getter to create a new computed balance variable that returns the value of the private variable. And this is a common technique that is often used when writing code in Dart, so you should be aware about it. Finally, I'd like to say that you can add an underscore not just to variables, but also to anything else that you want to make private. For example, here you could even make the entire bank account class private by adding an underscore, like this. However, that would mean that you wouldn't be able to create instances of this class because it is now private. So let me put this code back to the way it was before, and we can continue on the next lesson. We have now completed this section about the basics of classes in Dart, and with this knowledge you should now be able to create your own classes and work with constructors, member variables and methods, and also use getters and setters if needed. You can create class variables and methods using the static keyword and make things private when needed. And if there is one thing that I'd like you to take away from this section, is that class design is type design. And you can use all the techniques that we covered to design classes that are easy to use by yourself and other developers. Just like with many other things, getting good at this takes time and practice, and especially if you are new to classes, it can take a bit of time to digest all this information. So don't be afraid to experiment and start using classes in your own projects. In any case, classes are a broad topic, and in the next section we will talk about class inheritance and cover some more advanced concepts about classes. So for now, we will carry on and cover some of the more advanced content, and after the next section, we will do a new practical project so that you can build your confidence with all this new material. Okay, so let's continue in the next section. Welcome to this advanced section about classes in Dart. In this section, we will talk about subclassing, which is also known as inheritance, the superconstructor, overriding methods, and abstract classes, what they are and how to use them. We will learn about the difference between implements and extends. Then we will talk about the base object class as well as some of its methods and properties, such as the toString method, the equality operator, and the hashcode property. We will see how the equatable package can generate these methods for us, and we will talk about generics and how to use them with classes. And we will learn about the difference between composition and inheritance using the Flutter widget tree as an example. After that, we will talk in detail about factory constructors, and we will complete this section by covering copying objects with the copy_with method and the cascade operator. All this content will give you a much deeper understanding about classes so that you can use them with more confidence when you write your Dart or Flutter apps. So compared to the previous sections, some of this content is more advanced. But I believe it is very important because classes and object-oriented programming are fundamental topics in any programming language. So take your time to understand this content and don't be afraid to pause and get back to it later if you find some concepts difficult. Okay, so let's get started. Before we start learning about all the new content in this section, I'd like to say that from this point forward, we will no longer be using Dartpad. And instead, we will use Visual Studio Code to write our programs. And the reason for this is that VS Code is a much more productive development environment because it has shortcuts that we can use to auto-generate some of our code. And as we will see, this is particularly useful when we work with classes. So going forward, we will use VS Code. Also, we will use the latest Dart 2.10 SDK from the stable channel, which now includes null safety. So if you're using an older version of the Dart SDK, you'll need to update. To get started, you can go to this page where you can get the Dart SDK. And if we scroll down to the bottom, we can find this section about release channels. And at the moment, I can see that the stable channel points to version 2.10. And this is the version that you want to have installed on your system. So if you previously installed the SDK with a package manager, make sure to upgrade to the latest. Instead, if you already have Flutter installed on your system, then you need to make sure that you are running on Flutter 1.22 stable or above, as this already contains Dart 2.10. Alternatively, you can scroll down and click on this link to download the SDK as a zip file. And this takes us to the Dart SDK archive page. So here we can scroll down to the stable channel, and here we can find this link to download the corresponding Dart SDK. So make sure that your operating system is selected, and then you can click on this option to download the Dart SDK. And once you have downloaded this, you can move the downloaded file to a folder where you want the SDK to be installed. And once you have done this, you can double click to extract this zip file, and this will create a Dart SDK folder. Next, you want to update your system path and make sure that it points to this installation of Dart. And we have already done this before, but just as a reminder, let me show you the setup steps once again. So in my case, I'm running on macOS, and in order to update my path, I need to type open and then ~.zshrc like this. And this is a configuration file that contains a lot of settings. And inside here, I should type export. And here I want this to be all in lowercase, so autocorrect did the wrong thing here. And then path equals, and then I'm going to paste the system path where I copied the Dart SDK earlier on, making sure to add the bin subfolder at the end. And then after this, I'm going to type colon and then $path like this. And what this does is to concatenate this directory with the previous value of the path variable. So make sure that you use the path to the directory where you copied the Dart SDK. And once I made this change, I can save this file and close this editor. After this, I can open a new terminal, and here I can type Dart. And if everything is set up correctly, then I should see the usage description for Dart. And I can also confirm which installation of Dart I'm using by typing which Dart. And this will print the full path to the Dart executable that is in use. So this completes our Dart installation on macOS. If you're running on Windows, you have to follow a different procedure to set up your path. First of all, you have to select the search bar and type env, and then select the option to edit the system environment variables. Then you'll be taken to a System Properties dialog, and from here you need to select the Advanced tab and click on Environment Variables at the bottom. This will show all the environment variables for your current user, and here you need to select the path variable and click Edit. And on the next screen you can create a new line and add the directory that contains your Dart SDK. And after you click OK, you should be able to open a new command prompt, and over here we can type Dart -- version, and if we press enter, we should now see that we're using version 2.10 stable. And as a next step, we can create a new folder somewhere in our system, and we will use this to write the code for the lessons in this section. For example, here we can create a new classes advanced folder and move into it. Then we can type code dot to open VS Code on this folder. And as we know, here we can start creating new Dart files and add some code. But before we do that, we need to add a special file called pubspec.yaml, which is used to specify which dependencies our program needs, along with some other useful metadata. Now, this is a file that is automatically created for you when you start a new Flutter project. But because here we are using Dart only, we need to type this in by hand. So to make your life easier, I have prepared a copy of the pubspec.yaml file that you can download from the resources in this lesson. So you can pause the video and download this file, and then you can move it into the folder that we just created for this project. Okay, so you should have now downloaded the pubspec.yaml file and added it to your project in VS Code. So let's open this and take a look. Pubspec.yaml is a setup file that we can use to tell Dart which external packages we want to use in our project. And these are also called dependencies. In addition to that, we can use it to define an SDK environment variable, which tells Dart what is the minimum and maximum version of the SDK that is supported by our code. And as you can see, this file currently uses version 2.12.0 of the SDK, which is the one that we just downloaded. So by using version 2.12 or above, then null safety will be automatically enabled for our project. Okay, so now that we have this, we can open a terminal window, and in here we can type pub get. And when we run this, we want to see this output without errors. And also we can see that some additional files have been generated. So if you get any errors at this stage, try restarting Visual Studio Code and run this command again. By the way, if you have Flutter installed on your system rather than Dart as a standalone SDK, here you can also type flutter pub get. So either way, you should be able to run pub-get or flutter pub-get before you move forward. And if this doesn't work, I recommend that you follow all the steps in this lesson once again. Finally, we can create a new file called test.dart, and inside it we can add a void main method. And just to check that everything works, here we can type int a equals null. And when we do this, we should get an error telling us that a value of type null can't be assigned to a variable of type int. And this confirms that null safety is enabled. By the way, the reason I get this error hint is that I have installed an extension called ErrorLens. So I recommend that you install it as well so that you can see any hints, warnings and errors as you type your code. Okay, so we are now ready to get rolling with VS Code and null safety. So make sure that everything works before you carry on. And now we can delete this test file, which we no longer need, and we can continue on the next lesson. In this lesson, we are going to talk about subclassing in Dart. Subclassing is a technique that we can use to extend the functionality of an existing class so that we can increase code reuse. To show you how subclassing works, let's start with a simple example. So over here, we can create a new file called animal.dart. And here we can create a class animal And then inside the body, we can add a void sleep method, and we can use this to print sleep. Then we can add a main method, and inside it, we can create a final animal equals animal. And if we want, we can call animal.sleep. And if we click this link to run the program and open the debug console, we can see that the output is sleep. Next, let's see how we can extend this class. Over here, we can type class dog extends animal. And then inside the class body, we can add a void bark method that prints bark. Then in the main method, we can create an instance of dog and call dog.bark. But because dog extends animal, then dog has access to all the members and variables of animal. And this means that we can type dog.sleep. And this is because dog extends animal, which contains the sleep method. On the other hand, we can't call animal.bark, and that's because the method bark isn't defined for the type animal. So let me remove this line. And the process of extending an existing class is also called subclassing or inheritance. And when we do this, the subclass has access to all the methods and variables of the class that it is extending. And this class is also called the superclass. Next, let's add a new class cow, which also extends animal. And inside it, we can add a method, which is void moo. And this is used to print moo. And if we want, in the main method, we can type final cow equals cow. And then we can call cow.moo and cow.sleep. So what we have just done is to define a so-called class hierarchy. And at the top of this hierarchy, we have the animal class. And then we have created two subclasses called dog and cow. And if we wanted, we could extend this hierarchy even further. For example, here we could create a class clever dog extends dog, and this would have a method called void catch ball that would print catch. And then in the main method, we could create a final clever dog equals clever dog, and this would be able to catch the ball, bark, and sleep, because clever dog extends dog, and this in turn extends animal. So this is how subclassing works in Dart, and you can use subclassing to create class hierarchies that look like this. Subclassing is a tool that you can use to organize your code and model certain concepts in the real world. And as a general principle, you can use subclassing to model is-a relationships. And what I mean by this is that a dog is an animal, just like a cow is an animal. So in this example, dogs can do all the things that dogs do, along with all the things that all animals do. For example, sleeping. But dogs can't do the things that cows do, and vice versa. And what makes subclassing useful is that this animal class could have many additional methods, such as eat or move. And by defining these methods in the animal class, we can avoid repetition because we don't have to copy-paste them in each of the subclasses. Now, understanding when and how to use subclassing is not always easy, and subclassing is not always the right solution. In fact, one common alternative to subclassing is also known as composition. So as we continue on this section, we will learn when it's appropriate to use subclassing and when it's not. Okay, so let me remove these two methods and we can continue on the next lesson. Now that we know how to use subclasses, it's time to talk about superconstructors. So let's get back to our example using animals, and suppose that we want to add a new property to the animal class defining its age. And as we know, we can do this by typing final int age. And as we can see, we get an error saying that the final variable age must be initialized. So let's add a constructor, and in VS Code we can do this by selecting the age name, and if we press command dot, we get two options called add late modifier and create constructor for the final fields. So let's create a new constructor, and now that VS Code created a new constructor, we can move this to the top of the class by pressing Alt up. And let's also make this a named argument using curly braces and add the required modifier because this is a non-nullable variable. And we can also make this a const constructor. Then in our main method, we can create this instance of animal by passing age equals 10, for example. And now that we have done this, our animal class is fine, but we have some errors in the remaining classes telling us that the superclass animal doesn't have a 0 argument constructor. And this makes sense because we can only create instances of animal by calling this constructor that takes 1 argument. But neither the dog or cow classes are calling this constructor, and unlike some other languages, in Dart, constructors are not inherited by subclasses. So to fix this, we must provide a constructor for these classes as well. And we can do this by selecting the dog class name, and then we can use the magic wand to create a constructor to call super. And once we do this, we can see that this line is added. And the purpose of this is that we can call the super constructor inside the initializer list. So when you see this syntax inside a Dart class, you need to know that this is a call to the constructor of the superclass, which is specified here. And since this class takes a required name argument, then we need to pass this argument when we call super. And we can do this by typing age, colon. But what value should we pass here? Well, the logical thing to do is to add an argument to this constructor so that we can pass it to the constructor of the superclass. So here we can add some curly braces to define a required int age named argument. And then we can pass age to this argument in the superclass. By the way, note how when we declared the constructor of the animal class, we have used the this.age shorthand syntax because this class has an age member variable. But the dog subclass doesn't have an age variable, and this means that we need to declare this as a regular argument with a type and a name, so that we can pass it to the super constructor. So now that we know how the super constructor works, we can fix the cow and clever dog classes. And the quickest way to do this is to copy this line and paste it in here and here. And then we can update this constructor name to cow and this constructor name to clever dog. And now, whenever we create objects of type animal, dog, cow, or clever dog, we need to pass an age argument. For example, like this. So this is how the super constructor works. And if you decide to add more required or positional arguments to the animal constructor, you will have to update all the constructors in your subclasses. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about method overrides. You can use overrides to replace the implementation of a method that is defined inside a superclass with a more specialized version of it. As an example, inside the dog class, we can type void sleep, and we can use this to print dog sleep. Then, down in the main method, we can remove all these lines so that we only call animal.sleep and dog.sleep. And if we reveal the console and run the program, we can see that the output says sleep and dog sleep. This means that when we call this method on the animal object, then this method is executed. But when we call it on an instance of type dog, then dog sleep is printed. And that's because we have overridden the sleep method from the superclass. Now, one best practice that you need to keep in mind is that when you want to override a method, you need to add an override annotation. And in fact, VS Code is giving us a hint about it. So here we can use the magic wand and select Add Override Annotation. This is important because when your future self or other developers read this code, they will know that the intent was to override a method of the superclass. Override is also useful because if you try to override a method that doesn't exist in the superclass, for example, because you added a typo by mistake, then Dart can warn you about it. And now, suppose that we want to modify the implementation of this method so that it does two things. Execute the sleep method in the superclass and run some other code. To do this, we can replace the arrow annotation with some curly braces. And inside here, we want to call the sleep method in the superclass. Now, we might be tempted to just type sleep like this. However, this will not work because this code calls the sleep method inside the dog class recursively. And if we go down here and we run this code, we get a Stack Overflow exception. So this happens because this method calls itself over and over again until the virtual machine runs out of memory. So in order to call the sleep method of the superclass, we need to type super.sleep. And if we go back to the main method, we can comment out this line. And if we run the program again, we can see that sleep is printed. And if we want, inside here, we can add more code. For example, we could add one more line that says print sleep some more. So this pattern is quite useful because it allows you to customize the implementation of a method that is defined in the base class by overriding it and add some extra functionality to it. And method overrides are quite common when we use UI frameworks such as Flutter that define lifecycle events that control your application's state. In any case, we'll get some more practice with method overrides as we make progress. So let's continue on the next lesson. In this lesson, we are going to talk about abstract classes. Abstract classes are classes that cannot be instantiated. And as we are about to see, abstract classes are very useful in practice. So let's see how they work with a new example. So in our project, we can create a new file called shape.dart. And then inside here, we can type abstract class shape. And then inside it, we're going to add a double getter variable called area. And here we are not going to add a method body or the arrow notation with a return value, but instead we just add a semicolon at the end. Then we can add a void main method. And if we try to create a final shape equals shape variable, we can see that abstract classes can't be instantiated. And this means that if we want to use this, we have to create a concrete subclass of shape. So over here, we can type class square extends shape. And once we do this, we get an error saying missing concrete implementation of getter shape.area. To fix this, we can select the square class, and then we can use the magic wand to create one missing override. And as we can see, VS Code creates an override for the area getter variable with a to-do, telling us that we need to implement this, and also throws an unimplemented error. Now, this is some syntax that we will cover later in the course, but for now, all you need to know is that this will interrupt the execution of our program. Alright, so now that we have a square class, let's define a final double side that we can use to calculate the area. So let's add a constructor with the magic wand, and we can move it to the top. And now that we have this, we can replace this temporary code with side times side. And we can remove the to-do as well. And then in the main method, we can comment out this line, and we can type final square equals square with a value of 10. And then we can print square.area. And if we run this, we can see that the output is 100. Now, you may be wondering what is the point of creating a base abstract class called shape. After all, we could have declared only the square class and used it without worrying about subclassing overrides and abstract classes. So to show you why this is useful, let's add another subclass. So here we can add class circle extends shape. And then inside it, we can add a final double radius. And we can also add a constructor and move it to the top. And then we can use the magic wand to add the missing override. And then we can replace this code with pi times radius, which is the formula for the area of a circle. Now, pi is not a variable that is defined in this file. Instead, it comes from the Dart math library. So if we want to use this, we need to use the magic wand and import library Dart math. And as we can see, we now have an import at the top of the file. And now we can remove this to-do statement. And now we have an abstract shape class along with square and circle subclasses. Now, suppose that we want to create a function that can print the area of a shape. So here we can type void print area with an argument of type shape. And inside the body, we can print shape.area. And then in the main method, we can remove this line and we can replace it with print area square. And if we want, we can also create a final circle equals circle with radius 5. And we can also print area of circle. And the important thing to notice here is that this function takes an argument of type shape, but when we call it, we are giving it arguments of type square and circle. And this is possible because both square and circle are subclasses of shape. And just to prove my point, we could add an explicit type to these declarations and say final shape square and final shape circle. And this works because we can always assign an instance of a subclass to a variable of the parent class. Not only that, but here we could even declare a list called shapes. So this would be equal to a list, and then inside it we could put square 2 and circle 3. And then we could call shapes.forEach, and here we could use the shape argument to call print area of shape. And this works too, because Dart can infer that all the items in this list are shapes. So we can use forEach and pass each shape to the print area function. And if you remember what we said when we covered functions as arguments, here we can simplify this syntax and just pass print area as an argument to the forEach method, so that the shape argument is passed implicitly. But once again, this all works because these objects have a type that is a subclass of shape. So maybe now we can start to see why abstract classes are useful. And that's because they allow us to define an interface that can be implemented by various subclasses. And this is very powerful because it allows us to decouple the code that uses a certain interface from its implementation. In fact, in this example, the print area method doesn't need to know that square and circle even exist. All it knows is that it needs an argument of type shape and uses it to print the area. And by writing the print area method like this, we are following the so-called dependency inversion principle. This sounds like a fancy concept, but all it means is that we are coding against an abstraction so that the print area method is completely independent from any implementation of the shape class. And in programming, it's often a good idea to code against abstract interfaces rather than concrete implementations. Okay, so let's continue on the next lesson. It's now time to do an exercise using the classes that we have used in the last lesson. So given the following program that defines some shape, square, and circle classes, add a new perimeter getter variable to the shape class and implement it in all subclasses. As a little help, the perimeter of a square is equal to 4 times the side, and the perimeter of a circle is equal to 2 times pi times the radius. Then add a new print values method to the shape class, and when called, this should print both the area and the perimeter. Finally, create a list of shapes that contains squares and circles and call the print values method on each item. Okay, so you can spend some time completing the exercise, and as a reminder, you can get the starter code for this exercise on the course project on GitHub. Okay, so let's solve this together. First of all, we want to add a perimeter getter variable to the shape class, and we can do this by typing double get perimeter. Then we need to add the missing implementations on the square and circle subclasses. So here we can use the magic wand to add a missing override. Then we can remove this to do and replace this throw statement with 4 times side. Then let's do the same thing for the circle. So we can add the missing override, remove the to do statement, and replace this code with 2 times pi times radius. Then we need to add a print values method to the shape class. So here we can type void print values, and then inside the body we can print area with $area and perimeter with $perimeter. And finally, in the main method, we can create a final shapes variable equal to a list that contains a square with side 3 and a circle with radius 4. And then we can print all the values by typing shapes.forEach, and then we are going to use the shape argument to call shape.printValues. And now that we have this, we can open the debug console, and if we run this program, we can see that the area and perimeter is printed for both shapes. And the interesting thing to point out is that area and perimeter are getter variables that are computed by the shape subclasses, but the shape class can still use them if needed. Okay, so let's continue on the next lesson. In the previous example, we talked about abstract classes and seen that they allow us to define an interface that can be implemented by various subclasses. And to do this, we have used the extend keyword. And this is what we need when we want to subclass an existing class. However, in Dart, we also have another keyword called implement, which is used to create a class that can implement one or more interfaces. And if we wanted, here we could replace extend with implement, and this code would work exactly in the same way. So to better understand the difference between extend and implement, we need to talk about interfaces. So let me revert this, and here we can create a new file called interfaces.dart. And inside here, we can type abstract class interface A, and inside its body, we can add a void A method. Then we can create another one called abstract class interface B, and inside it, we can add a void B method. And both these methods are abstract. Then let's create a new class called AB that implements interface A and interface B. And once we have done this, we can see that we get an error that says missing concrete implementations of interface A and interface B. To fix this, we can select the class name and use the magic wand to create the two missing overrides. And now that we have done this, Dart is happy. Now, the important thing to notice is that in Dart, a class can implement more than one interface, and that's exactly what we have done here. On the other hand, if we try to replace implements with extends, then we get an error telling us that each class definition can have at most one extend clause. What this means is that in Dart, new classes can only extend one class. So let me revert this change and put it back to implements. Now, there are also other differences between implements and extends. So let's consider a different example. And over here, we could type abstract class base, and then inside it, we could declare a void foo method, which is an abstract method, and also a void bar method. And here we could use this to print bar like this. And this is valid code because when we create a method inside an abstract class, we can choose to provide an implementation, but we don't have to. And methods that don't have an implementation are also called abstract methods. And now that we have this, we can create a class subclass extends base, and then the compiler will tell us that we are missing a concrete implementation of base.foo. And that's because foo is not implemented in the base class. However, it doesn't tell us that we are missing a concrete implementation of base.bar because bar is implemented in the base class. So when we use extend, we are only required to implement the methods that are not implemented in the base class. And we can do this by creating the missing override. And here we could replace this method body with print foo. On the other hand, here we could have chosen to write class subclass implements base. And this time we get an error saying that we are missing a concrete implementation of base.bar. And that's because when we implement a class, we must override all its methods, even if they are already implemented in the base class. Okay, so we have now seen what interfaces are and what is the difference between extend and implement. And we have to follow a lot of different rules depending on how we use abstract classes, extend and implement. So let me do a summary. When we create a new class, this can only extend a single class, but it can implement multiple classes or interfaces. When we extend a class, all abstract methods must be overridden and other methods can be overridden. But when we implement a class, all methods must be overridden, even if they already have an implementation. And the reason things are this way is that in Dart, every single class has an implicit interface, meaning that if we want, we can even implement a non-abstract class, provided that we override all its methods. By the way, I'd like to say that some programming languages have a very clear distinction between concrete classes and interfaces with nothing in between. So you can think of a concrete class as a class that is not abstract and it implements all the methods that it defines. And because of this, you can create instances of that class. On the other hand, you have interfaces, and in Dart, interfaces are defined with abstract classes that have all abstract methods. But in Dart, it's also possible to define abstract classes that have some abstract methods and some non-abstract methods. Okay, so I hope that this explanation has clarified how to use extends and implements with abstract and concrete classes. And if some of these rules are still not completely clear, don't worry, because we will get more practice working with abstract classes as we make progress. By the way, in addition to regular and abstract classes, in Dart we also have mixins and extensions, which give us more ways to extend the functionality of our classes. And we will cover mixins and extensions in the next section. Okay, so let's continue on the next lesson. Now that we know about classes and inheritance, we can talk about the object class. You see, every single type that we have encountered in Dart is a subclass of object. For example, the int and double types that we have used are subclasses of a class called num, and this in turn is a subclass of object. String and bool are subclasses of object, and so is the map class. Lists and sets are subclasses of iterable, and this in turn is a subclass of object. And this means that object is the root of the Dart class hierarchy. Though if I had to be precise, I should mention that the introduction on null safety changes this by introducing the object question mark and never types. Though at this stage, this is not an important detail, and if you're interested in learning more, you can read this page about understanding null safety on the Dart website. But as far as we are concerned, then this diagram is good enough for us. And the reason things are this way is that having a root object class makes it easier to work with the type system. For example, if you ever wonder why it is that you can pass any object you want to the print method, that's because the print method takes an argument of type object. And because all types are subclasses of object, then we can pass anything we want to the print method. This also means that when you have an object of any class and you use the .access operator, this list will reveal all the methods and variables that are available for that object's class, as well as all its superclasses, including the object class. And just to be clear, when you create a new class, you don't need to extend object, because all classes are subclasses of object by default. This means that inside a method, you could type super dot, and here you will see all the methods and variables inside the object class. And it's quite important to know about some of these methods. So let's continue on the next lesson where we will explore them in more detail. In this lesson, we are going to learn about the toString method. ToString is a method inside the object class, and it is very useful for debugging purposes because you can override it to define a string representation of your own types. Now, all the built-in types such as int, string, or list already implement the toString method. As a proof of this, let's create a new file called point.dart and add a void main method inside it. And then we can declare a list like this with the values 1, 2, 3. And if we print it, then we can run this program. And as we can see, here we get a useful string representation of this list. And that's because the print method automatically calls the toString method for us. But sometimes we need to define our own classes. For example, here we can define a simple point class, and inside it we can add x and y coordinates. And as usual, we can add a constructor, and we can make this a const constructor. Then we can remove this code, and if we print an instance of point with coordinates 1 and 1, and we run this, we can see that the output is instance of point. And that's because we haven't implemented the toString method. To fix this, inside this class, we can start typing to, and then we can select toString from the list of options, and this will create the correct method override for us. Then we can replace this method body and use the arrow notation to return a string that contains the value point, and then within parentheses, $x and $y with string interpolation. And if we open the console and run the program now, we can see that now the output contains the values of the coordinates, and this is much more useful. Not only that, but if we want, here we can create a const list equal to a list that contains the values point with 1 and 2 and point with 3 and 4. And if we print this list and we run the program now, then Dart will use the toString method that we have implemented to print the values of each point. And this means that you can get a human-readable string representation of complex objects using collections and nested classes, as long as you override the toString method in your own classes. So the bottom line of this is that when you create your own classes and you want to print the values of their member variables, then it's a good idea to override the toString method. This is particularly useful when you are defining model classes that represent some objects in the real world, such as a person or an employee. Okay, so let's continue on the next lesson. In this lesson, we are going to talk about equality and what it means for two objects to be equal. So let's clear this code on the main method. And here we can type print 5 equal to 5. And if we run this code, then we can see that the output says true. On the other hand, we could replace this expression with point of coordinates 0 and 0 equals to point 0, 0. And if we run this program now, we can see that the output is false. And this is a problem because we have created 2 points that have exactly the same values and we expect them to be equal. However, the point class is a new type and we haven't told Dart how to compare instances of type point. So if we want to reliably compare instances of new classes, then we must implement the equality operator. So let me show you how this works. Over here, we can type @override and then bool operator equal, and then we can open parentheses and inside we can add an object other argument. So what we have done here is called operator overload. And operator overload allows us to define how an operator works when it is applied to a new type. And in this case, we are interested in the equality operator because that's what we use to compare these points over here. And then we need to pass an argument of type object because the equality operator works with 2 operands, one on the left side and one on the right side. So in this case, the left-hand side operand is the current instance which already has x and y variables, and the right-hand side operand is passed as an argument. However, here we are not allowed to use point as the type of the argument because the equality operator inside the object class has an argument of type object, and when we override a method or operator, all the arguments must match. Besides that, if we wanted, here we could type point equal to a string literal, and when this code runs, then the equality operator will be called with a value of type string, which is a subclass of object. So let me revert this. And the bottom line here is that we need to check that at runtime, this object is actually of type point before we can compare its coordinates. And to do this, here we can type if other is point, and then inside the body, return x equals to other.x and y equals to other.y. And otherwise, we just return false. By the way, note how here we can type other.x and other.y, even though other has type object when it's declared as an argument. But object doesn't have x and y properties. So this code works because when we check that this value is a point, then Dart can promote it to a point inside the if statement. And now that we implemented the equality operator, we can run our program again. And this time we can see that the output is true. On the other hand, if we compare a point to a string literal and we run this, then the output is false. So this is what we expect, but it would be nicer if there was a way to tell Dart that this code shouldn't even compile, because it doesn't make sense to compare points to string literals. And to do that, we can use a special keyword called covariant. So when we declare this argument, we can add the covariant keyword, and then we can change this type to point. And now that we have done this, we have an error that says the argument type string can't be assigned to the parameter type point. So by using covariant, we are allowed to change the type of an argument when we override a method from a superclass. In other words, here we are saying, hey Dart, I want to only override this operator when it is called with an argument of type point. And I want it to be invalid to call this operator with any other type. And because this argument is now guaranteed to be of type point, then we don't need this if statement. And we can just return this expression. Okay, so let's continue on the next lesson. in this exercise, I'd like you to expand the point class that we have created in the last lesson. So given the following program that defines a point class and a main method, implement the plus operator so that it's possible to add two instances of type point, and also implement the times operator so that it's possible to multiply a point with an int value. Once you have done this, the print statement in the main method should compile and print the correct result. As a reminder, you can find the starter code in the course repository on GitHub. So you can try to solve this by yourself, and then I'll show you the solution. Okay, so let's do this together. And we can start by implementing the plus operator. To do this, we can type point operator plus, and then within parentheses, point other. And then inside the method body, we can return a point, and the first argument will be x plus other.x, and the second will be y plus other.y. And the return type should be a point, because we are adding the values of each coordinate and then return a point. And as we can see, now that this operator is implemented, then this line becomes valid. Next, let's implement the multiply operator. So this time we can type point operator star, and then inside parentheses int other, and inside the body we can return point with x times other and y times other. And as we can see, our program is now valid, and so if we run this, we can see that the result is point of 3 and 1 and point of 10 and 5, which is what we expect. Okay, so let's continue on the next lesson. Now that we have learned about toString and the equality operator, we need to focus on another important variable that is declared inside the object class, and that variable is called hashCode. So let's start by typing hash, and then here we can select the first option to automatically override this variable. So what is a hashCode exactly? Well, if we wanted, we could select this, and then we can command click or control click to reveal the documentation. And if we scroll up, we can learn a lot of useful things about hashCode. And in general, I always recommend that you read and try to understand the documentation when you encounter something new. For now, the important thing to remember is that two objects that are equal should have the same hashCode, and two objects that are not equal should have different hashcodes. And for this reason, you should always override the hashCode getter variable whenever you override the equality operator. In fact, let me put them together because they should belong together. Now, choosing good hashcodes is a problem that is not always easy to solve, and definitely not a problem that you want to solve every time you create a new type. And in fact, there is a whole thread about this on Stack Overflow. And the most upvoted answers suggest to use packages such as Quiver and the Equatable package that can solve this problem for you. So what we are going to do at this stage is to go to pub.dev, which is the place where you can find all the Dart and Flutter packages that you need. And then on the search bar, you can type Equatable, and then in the search results, we can select the first result. And we are taken to this page that contains all the information that you need to install and use this package. So for now, I'll show you how to do this, since this is the first package that we install, but keep in mind that most well-maintained packages have clear instructions that you should be able to follow. Okay, so let's get back to our project, and what we want to do is to open the pubspec.yaml file that you have downloaded at the beginning of this section. And then we need to locate the dependencies section over here. And this is the place where we can declare all the packages that we want to install. So we can add a new line, making sure to leave 2 blank spaces at the beginning. And here we can type Equatable : followed by the version number. So here I'm putting 1.2.5. But if you see a more recent version on pub.dev, you can use that. Then you can save this file, and when you do this, you should see pubget installing the package. And if you prefer to do this manually, you can click on this button that says Get Packages, or even open the terminal and type pubget. Okay, so this has now installed the Equatable package and we are ready to use it. So let's get back to the point class. And in the class declaration, we are going to type extends Equatable, and then we can press command dot or control dot to import the library Equatable. And now that we have done this, we get a new error telling us that we are missing a concrete implementation of getter equatable.props. to fix this, over here we can start typing props, and then we can select the first option, and Dart will override this getter variable for us. Then all we have to do is to replace this throw expression with a list that contains the values x and y. And we can remove this to-do statement. And now that we have done this, we can remove the hash code override, because Equatable will take care of overriding it for us using the list of props that we have specified here. Not only that, but Equatable will also override the equality operator for us based on these properties. So here we can remove this override as well. But there is more, because if we want, Equatable can even generate the toString method for us. And if we want to enable this, here we can start typing stringify, and then we can select this, and here we get a new override that we can use to return true. And now that we have done this, we can remove the toString override as well. So let's get back to the main method and remove all this code, and we can check that everything still works. So here we can type print, and then point with values 0, 0 equals to point with values 0, 0. And then we can also try to print a point with values 1 and 1. And now we can run this code. And as we can see, the first line prints true, and the second line is a human readable description of the point values. And all of this happens because the Equatable class does the right thing for us. In summary, we have seen that it's good practice to override the equality, hash code, and toString methods when we create our own classes. And if we have a lot of classes, it can become tedious to override all these things. Luckily, the Equatable package solves this problem for us. So all we have to do is to install it in the pubspec.yaml file, and then we can add extend Equatable to our classes. And finally, we have to override the props getter variable and list all the member variables inside our class. And if we want the toString method to be implemented as well, we can override the stringify getter variable and return true. And this is much less work than overriding all the methods ourselves, and it's also less error prone. Finally, I'd like to point out that you should only use Equatable on immutable objects, so all your member variables must be final. So make sure to keep that in mind. Okay, so let's continue on the next lesson. In this lesson, we are going to talk about using classes with generics. As a reminder, when we talked about functions, we said that generics give us a way to write code that is more reusable because it can work on different types. And we have seen that generics are used heavily with functional operators such as map, where, and reduce. And the same concepts apply when we work with classes. As an example, let me show you how we could implement a class that represents a stack using generics. A stack is a data structure that is used in many computer science applications, and we can use it to push and pop values. For example, here's a stack with just one item, and if we want, we can push an item into the stack. And every time we do this, a new value is added on top of the stack. On the other hand, when we pop values, these are removed from the top of the stack, so that we always remove the most recent value. So let's see how we could implement a stack that uses a list as internal storage. First of all, we can create a new file called stack.dart, and over here we can type class stack, and we can add a couple of angular brackets to define the type t. And inside this class, we can create a final list of type t of items. And here we use an underscore because we want to make this private so that it can't be accessed directly from outside the class. And then we're going to initialize this with an empty list by default. And then we can add a new void push method. And this takes an item of type t, and we can use this to add the item to the list. In addition to this, we should have a pop method that we can use to pop items out of the stack. This method should have a return type of t, and then we can use it to return items.removeLast. And now that we have this, we can create a void main method and create a final stack equals stack, and we can choose any type we want, for example int. And then we can use this and type stack.push1 and stack.push2. And then we can add a print statement, and inside it we could type stack.pop. And if we run this program, we can see that the output says 2. And that's because this is the last value that we pushed into the stack. And if we pop one more time, and run the program again, then the output says 2 and 1 as the items are popped in reverse order when we use a stack. And since we are using generics, we can use the same stack class to create a stack of strings. For example, we can type final names equals stack of type string, and we can push values such as Andrea and Alice. So what I'd like to point out is that here we have been able to implement a simple stack class with just a few lines of code. And that's because we already have a list class that offers all the functionality that we need to add and remove items. So this is a good example of composition, which is a very important design pattern. So let's continue on the next lesson where I want to talk about composition versus inheritance. In the last lesson, we have created a stack class that uses a list internally, and we said that this is a good example of composition. So if we think of a stack and a list as entities and try to describe the relationship, we can say that a stack has a list. This is in contrast to inheritance, which is another pattern that we have learned in this section. And as we have seen, we can use inheritance to model an is-a relationship. For example, a square is a shape. And when we write code, understanding the correct relationship between entities is important. For example, in Flutter, we use composition heavily to describe how our application's UI looks like. And in Flutter, everything that we draw on screen is called a widget. So let me show you how we could write a very simplified version of the widget class hierarchy in Flutter. So let's create a new file called widget.dart, and inside it we could add an abstract class widget with an empty body, and this would be the base class for all widgets in Flutter. This class is abstract because it's up to subclasses to decide how to draw things on screen. For example, here we could add a class text which extends widget, and this could have a final string text variable, and this represents the text that we want to draw. As usual, we can add a constructor and move it to the top. Then we could define a class button which also extends widget, and this would have a final widget child, as well as a final void function type, and here we could type question mark and then onPressed. So we could use this to define a nullable function type that is called every time the user presses on the button. And this class would also have a constructor, and this should have named arguments, and we could make the child argument required because it is non-nullable. And so what we have here is a simple class hierarchy that defines a base widget abstract class and two subclasses called text and button that represent specific UI widgets. And we are using inheritance because a text is a widget and a button is a widget. But inside the button class, we use composition to specify a child widget. So let me show you how we can use this. Here we can create a void main method, and inside it we can add a final button equals a button, and this takes a child widget as an argument. So here we can pass a text widget that says hello. And if we want, we can add the onPressed argument, and this is an anonymous function that can print button pressed. Now, this is just a simple example, but it already shows the power of composition because the button class doesn't know what kind of child it should have. All it cares about is that it is given a child widget. And because all widgets have the same base widget class, here we can pass any widget we want as an argument. And this approach is very scalable because we can use composition to combine widgets together and create complex UIs. So on one hand, when you write apps in Flutter, then you can use composition to define how your UI looks like. And inside the Flutter SDK, both inheritance and composition are used to create an extensive catalog of widget classes. So the bottom line of this is that composition and inheritance are both very important. And once again, you can use composition to model has-a relationships, and you can use inheritance to model is-a relationships. Okay, so let's continue on the next lesson. Now that we are familiar with inheritance and subclassing, we are ready to talk about factory constructors. This is a topic that many students have requested, so in this lesson we'll learn how to use them. And one of the most common use cases for factory constructors is parsing JSON data, which is a very common task that many applications need to do. So this is going to be a long lesson that will also round up some extra details that we haven't covered until now. So let's get started. As a reminder, in the previous section we have already talked about default and named constructors as well as static methods. So let's see what factory constructors are and how they are different. Factory constructors are useful in two kinds of scenarios. One, when we need to implement a constructor that doesn't always create a new instance of its class. And two, when we need to initialize a final variable using logic that can't be handled in the initializer list. And a good case for this is when we are parsing some data that comes from the network, and this is typically stored in JSON format. And in Dart, we can represent JSON data using a map of key value pairs. As an example, consider the shape, square, and circle classes that we have implemented a little while ago. And to make things interesting, suppose that we are building a program that we can use to show different shapes on screen. These shapes can be stored inside a database on the server, and our client application can request a list of shapes to be drawn on screen. When the server receives the request, it sends back a response containing JSON data, which may look like this. And when the client receives the data, it needs to process it and map each item into a shape instance. And this can be done with a factory constructor. So let's get back to Visual Studio Code. And to make things easier, we will start from the original code that we had written when we implemented the shape, square, and circle classes. So here we can remove all this code from the main method, and then we can type final shapes JSON equal to an empty list literal. And then inside it, we can add a map that contains two key value pairs. The first one will be type with a value of square, and the second one will be side with a value of 10.0. Then we can do the same thing and create another map with a type of circle and a radius of 5.0. So our goal is to map all these items into a list of shape objects. To do this, we can scroll up to our shape class, and here we can type factory shape dot from JSON. So this syntax is the same as what we use when we declare a named constructor with an additional factory keyword over here. Then as an argument, we can add a map of string and object, and we can call this JSON. And the reason we use object here is that the values that we get from the JSON data can be strings or doubles. So object is a good choice because it is the superclass of all classes in Dart. And I know that previously we had used the dynamic keyword for the values inside our maps. But now that we know about object, I recommend that we use this instead, as the type system can be a little bit more helpful when we do this. Okay, so let's implement the body of our factory constructor. And here we can type final type equals JSON and then type as the key. And then we are going to use a switch statement to decide which kind of instance we are going to return. So let's add a switch type, and inside we can type case square, and inside this case we can declare final side equals JSON of side. And here we could try to return a square with side as an argument. But when we do this, we get an error telling us that the argument type object ? Can't be assigned to the parameter type double. This happens because it is not guaranteed that we have a value for this key, and this variable could be null. And even if it's not null, it's not guaranteed to be of type double. And we can fix both these problems by typing if side is double, and then we can only return square if this condition is true. But what should we do when side is null or is not a double? Well, when we use a switch statement, we should either break, return, or throw an error at the end of each switch case. But if we reach this line, that's because we couldn't read the side variable, so we can't create a square object. But we also can't return null, because we are inside a factory constructor, and this is supposed to return an object of type shape. So the only option we have left is to throw an error. So here we can type throw unsupported error, and this is a class that takes a message. So inside it we can type invalid or missing side property. Now we have not talked about error handling yet, and we will cover this later in the course. But for now, all you need to know is that this statement will cause an exception that will interrupt the execution of our program. So let's continue by adding the code to create a circle object. Over here, we can type case circle, and then inside it, final radius equals JSON with radius. And just like we did before, we can check if radius is double. And if it's true, then we can return a circle with radius as an argument. Otherwise, we can throw an unsupported error that says invalid or missing radius property. But our job is not done yet, because we need to handle the case where the type is not a square and not a circle. So let's add a default clause, and inside it we can throw an unimplemented error, and this also takes a message, so we can say shape $type not recognized. So once again, we will talk about error handling and exceptions later on. Okay, so our factory constructor is now ready to use, but we are still getting this error that says the class square cannot extend shape because shape has only factory constructors, no generative constructors, and square has at least one generative constructor. Now, this sounds complicated, but what it actually means is that the constructor of square has no way of calling the constructor of the base class. Now, if the base class doesn't have any constructors at all, then Dart will generate an implicit constructor that takes no argument. But in this case, we have added a factory constructor, and so the implicit constructor is no longer generated. So the solution to this is to explicitly define a default constructor for the shape class. And this can just be called shape, like this. And we can make this a const constructor because this class doesn't have any mutable variables. And once we have done this, then all the errors are resolved. And while we are here, we can make these constructors const as well. Okay, so we are finally ready to use our factory constructor. So we can get back to the main method, and here we can type final shapes equals shapes.json dot map, and then for each shape JSON argument we can return shape.fromJSON with shape.json. So what this code does is to take each one of the maps inside this list and passes it to the shape.fromJSON factory constructor. And then we can type shapes.forEach, and then we can pass print area as an argument. And if we open the console and run this program now, we can see that these two areas are printed. And if we want, we can even test the error handling logic. For example, here we could add one more map and use a type of triangle, which is not a type that is supported. And if we run the code now, we can see that we get an exception that says an implemented error, shape triangle not recognized. And this is the error that we are throwing over here. Okay, so let's do a recap of what we have learned. Over here, we have created a factory constructor that we can use to map key value pairs into objects of type square and circle. Now, when we use regular constructors, we always return an instance of the class itself. But with factory constructors, we can return an instance of a subclass, such as square and circle. In addition to that, this code has some conditional logic to switch on the type of the shape, as well as some defensive logic that we can use to ensure that all the values that we get are of the correct type. And especially when reading JSON data that comes from a server, it's a good idea to add this extra logic because it makes our code safer to use. And adding all this conditional logic is not something that we can do with regular constructors. And one thing that I'd like to point out is that if we wanted, here we could replace this constructor with a static method that returns an object of type shape. And this is easy to do because we can just replace factory with static and make this a method called fromJSON that returns a shape object. And this code will work just fine. However, by convention, when you want to initialize a class instance, such as in this case, then it's recommended to use a factory constructor. So let me revert this change. And I'd like to say that there are some other subtle differences between factory constructors and static methods. And if you want to learn more about this, you can read this article, which contains a lot of detailed information about factory constructors. In any case, we have now covered all the different kinds of constructors that are available in Dart, and you can use all the code and examples that we have written as a reference when you need to decide which constructors to use in your programs. Okay, so let's continue on the next lesson. In this exercise, I'd like you to get some practice working with factory constructors. So here we have a program that implements a person class with name and age properties, and we have a main method that tries to create a person instance from a map of key value pairs, and then converts that person back to a map and prints it. So I'd like you to implement a factory from JSON constructor so that it's possible to create person instances from a map of key value pairs. This should handle the case where the name and age values are missing or have the wrong type. And you should also implement a toJSON method so that a person instance can be converted back to a map of string object. And as a reminder, you can find the starter code for this exercise on GitHub. So try to go ahead and solve this by yourself. Okay, so let's see how to solve this. First of all, we want to implement the from_JSON factory constructor, so we can remove this line, and here we can type factory person.from_JSON, and this takes a map of string object, and we can call this JSON. Then inside the body, we can declare a final name equals JSON with name, and final age equals JSON with age. And then we need to check the type of name and age. So we can type if name is string and age is int. And if this condition is true, we can return a person with name, and age. Otherwise, we can throw a state error, and as a message, we could use could not read name or age. And for now, we don't need to worry too much about which specific class we use for this error. For example, here I have used state error, but you could have used an implemented error or unsupported error. The important thing is that we throw an error if we can't read the name or age. Okay, so our factory constructor is now complete, and now we can remove this to-do and implement the toJSON method. So this is quite easy because all we need to do is to type map of string object to JSON, and here we can use the arrow notation to return a map that contains the values name with name and age with age. And now our program is valid, so we can run it, and on the debug console we can see that the output is name Andrea and age 36. And if we wanted, here we could pass an invalid age value, for example by using a string literal. And if we run the program again, we can see that this time we get an exception. And this confirms that our error handling code works. And just to be clear, the reason we added a toJSON method is that sometimes we want to save some data to a remote database, and to do that we need to be able to represent our data in JSON format. Okay, so let's continue on the next lesson. In this lesson, we are going to talk about copying objects in Dart. And as a reminder, when we started working with classes, we said that it's often better to create immutable classes that only have final properties. This approach leads to code that behaves in a more predictable way because it minimizes the amount of mutable state that we have in our applications. However, sometimes it's useful to take an instance of a certain class and make a copy of it so that we can modify some of its properties. As an example, here we can create a new file called credentials.dart. And then we can create a class credentials, and inside it we can add a final string email and a final string password. Then we can create a constructor for this class and make these named arguments using an empty string as a default value. And we can also make this a const constructor. Then we can add a void main method, and inside it we can create a const credentials equals credentials. Now, suppose that we are creating a sign-in form where the user can type in an email and a password, and we want to update this credentials object as the user types in the form. But because we made these variables final, here we are not allowed to type credentials.email and set it to some email address. So instead, the only thing that we can do is to create a new credentials instance using the values from the previous one. And in order to do this, we can create a method called copyWith. So let me show you how this works. Over here, we can type credentials copy with, and this is a method that takes two named arguments. The first one is a string email, and the second one is a string password. And we can use this to return a credentials object with email equal to email this.email and password equal to password this.password. And the way this method works is that it returns a new credentials instance that uses the email that is passed as an argument if it's not null. Otherwise, it uses the email from the current instance. And we can do this with the if null operator. And we can do the same thing for the password as well. And while we are here, we can also implement the toString method. So here we can add an @override and then string toString and use the arrow notation to return a string literal that contains credentials with $email and $password. And now in the main method, we can type final updated one equals credentials.copyWith email, and we can pass an example email, and then we can print updated one, and then final updated two equals updated one.copyWith password, too easy, and then we can print updated 2. And now we can run this program and we can see that it prints these 2 lines. And this confirms that the first time we call copyWith, then we are setting the email and keep the previous password, which is empty. And the second time we do this, then we keep the previous email, but we set the new password. And all of this is done using only immutable objects. In summary, when you need to implement copy behavior for your immutable objects, you should implement a copyWith method that uses this syntax to update each property. And this is a convention that is used extensively in Flutter, especially when it comes to setting theme objects that can have dozens of properties. And what makes copyWith so convenient is that we can use it to set any properties that we like while omitting all the others, and this is done using named arguments. Okay, so let's continue on the next lesson. In this lesson, we are going to learn about the cascade operator. The cascade operator is often used when we work with classes that have some mutable state inside them. For example, let's create a new file called path.dart. And in here, we are going to create a class closed path, and then inside it, we can declare a list of type point underscore points equals to an empty list. So this is going to be a private variable. And because the point class is not defined inside this file, we need to import it. So we can select the magic wand, and here we are going to import library dart.mat like this. And as we can see, this class defines a point using 2 coordinates x and y. Then we can add 2 methods to this class. The first one is called void move2, and it takes a point argument, and inside the body we can say points equal to a list that contains that point. So all this does is to set this variable with a list that contains just 1 point. The second method is called void line2, and it also takes a point argument, and we can use it to say points.add point. So what this does is to add a new point to the list. So let's see how we can use this class. Over here, we can create a void main method, and inside it, we can type final path equals a closed path instance. And we are going to use this to represent a square. So here we can type path.move2, a point with coordinates 0 and 0. And then we can type path.line2, a point with coordinates 2 and 0. And then we can add another line to a point of coordinates 2 and 2. And then once again to a point of coordinates 0 and 2. And finally, we can do a final line back to the point of coordinates 0. So here is a representation of the path that we just created on a 2-dimensional plane. Now, this code works, but as we can see, it is a bit verbose because we need to type path dot every time we want to add a segment to our path. Luckily, there is a better way, and that is to use the cascade operator. And the way this works is that when we have an instance of a closed path, then we can type dot dot and call one of the methods. And then we can repeat this operation multiple times, remembering to add a semicolon on the last line. And this code behaves exactly in the same way as what we had before. And the way this works is that the cascade operator will call the method that we have specified, and then it will return the current instance. And this means that we can use this syntax to cascade multiple method calls like this. In summary, the cascade operator is nothing more than syntactic sugar, and it is very common to use it when we have classes that are mutable, such as this closed path. And since we recently talked about the benefits of using immutable objects, you may be wondering if we should make this class immutable as well. And if we wanted to, we could do this and simply pass a list of points as a constructor argument and create something that looks like this. Though in practice, many APIs that are used to draw paths have this kind of syntax, where we first move to a point and then add one or more lines by calling line 2. In any case, I just wanted to show you how the cascade operator works. And by the way, you should be aware that this operator also has a null-aware variant that you can call by adding a question mark right before the first cascade operator in the chain. And this is useful if it's called on a variable that is nullable, but this is not the case here, so we can remove this. Okay, so we have now completed this section about classes, and I feel that we have learned a lot along the way. So make sure to practice and apply all the things that you have learned in your own projects, as this is a great way to consolidate your knowledge. And as I said before, if you found some of this content difficult, don't be afraid to get back to it later if you need to. Okay, so let's continue on the next section. In this section, we are going to work on a new practical project so that we can apply some of our new knowledge about classes. And this project is all about e-commerce. When you go on a website such as Amazon, you can search for the items that you need and you get a list of search results that matches your criteria. And when you find the products that you want, you can add them to a shopping basket. And from here, you can check the contents of your basket and proceed to a checkout page. Now, a website like Amazon has a huge amount of features, such as product reviews, as well as a recommendation engine that helps you find what you want. But the essence of any e-commerce website is that you have a product list, and you can select some items from this product list and put them in your cart. And finally, you can check out to complete your purchase. And in order to make this possible, you need to add some UI so that the user can interact with your website, as well as a remote database that contains the updated product list and store the items that the user saves in the cart. And you also need some business logic that sits in between the UI and the database, and this is the code that you write to add items to the cart. So in this project, we will not build a full e-commerce website, but instead we will focus on this business logic and try to build a simple e-commerce flow as a command line app in Dart. So forget about Amazon and instead think more along the lines of a local fruit and veg shop, where you can go and pick some items, and when you are done, you go to the till and pay in cash. And in fact, this is not even an e-commerce project, so we can drop the E and build a simple commerce application. And once we are done with this project, we'll be able to run it on the command line. And here we can choose to view the items, add an item to our cart, or checkout. So we can use this interactive prompt to add some items. And every time we do this, we get a summary of what's in the cart. And at the end, we can check out and pay in cash and get our change. And even if this is a relatively simple application, it is a great way to practice working with classes. And before we write any line of code, I think it's useful to better understand what entities we need to build this app. To start off, we need a product entity that we can use to represent a product on sale in our shop. Each product has a unique ID, a name, and a price. And over here, we have an example product list with some names and prices. When we enter the shop, we want to choose some of these products and add them to our cart. And because we can choose a product more than once, we need that item entity that represents the product along with the quantity that we want. Finally, we have a cart entity that contains all the items that we have chosen, and the cart should be able to calculate the total for us. And because the product, item, and cart are entities in the real world, I suggest that we represent them using classes. And since we are building a command line app, then we will need some extra logic to build our interactive prompt and add items to the cart. So let's continue on the next lesson, where we will start building this app.